Welcome back to another installment. Today we are going to be looking at electron configuration, and this is going to be in addition to our original electron configuration video, as well as a continuation of our proton, neutron, and electron chart. So if we want to go ahead and just do a quick review, uh, we know that when we're dealing with elements on the periodic table, they are in their neutral state. And what I mean by neutral state is in order for us to have an element, there are certain aspects in what I consider eight, which is another light bulb moment for those who are familiar with my videos. Eight in the sense of electron configuration and dealing with protons, neutrons, and electrons is that our atomic number, our number of protons, and our number of electrons are all equal. Okay? And what determines our charge for our elements is the ratio of electrons to protons. So as I stated before, as they appear on the periodic table, they are in their neutral state. So if we were to see calcium, we know it is normally written capital C, lowercase a. And there's an understanding, like I stated, that it is a neutral charge or there is no charge there because it has an equal number of protons and electrons, which are our positive and negatively charged subatomic particles. So when we begin to write electron configuration, we then look at our periodic table, and please make sure to reference the one that is approved by your course and or your school so that all of your answers are congruent or succinct with your professor. When you look at the periodic table, there are different subsections within your periodic table. So we have what is called the S block, which is going to be your first two columns that start with hydrogen in the top of beryllium, but it also includes helium. And helium is on the far side of the periodic table because it is, in fact, one of those noble gases, okay? Then we have here our six from boron over to neon and down. That is going to be our P block, okay? And then we also have here the D block, okay? So as far as the course that we are making this video for, we are going no further than this D block. So there are certain rules, of course, when dealing with naming and configuration within the D block. So please make sure that you reference our previous electron configuration video. But let's go ahead and get started with calcium. And then we're going to dig into what happens when our normal elements become ions, okay? So when we're dealing with calcium, in order for us to do that electron configuration, we are going to consider all of the places in which we have to pass in order to reach calcium. Okay? So calcium we know is all the way down here at position 20 on the periodic table. So we're going to go completely through the first S block. So it's going to be row 1, S block, and both of those elements. So the first thing we would end up writing is going to be 1s2, stating we went through the first row, the whole S block, and both of those elements. We then go down to 2s2, because we're then in the second row, the S block within that second row, and we're going to go through both of those elements there. That then brings us to boron, which is going to be still in that second row, but we are now in the P block. And we're going to go through all 6 of the elements there, from boron to carbon to nitrogen, oxygen, fluorine, and neon. So that tells us we're going to go all the way through those 6. Okay, we're now to our third row that starts with sodium. So we have third row, S block, and we're still needing to go through sodium and magnesium. So those are those 2 elements in the S block of the third row. We're now to the third row, but within the P block. And we go from aluminum to silicone, phosphorus, sulfur, chlorine to argon, and we still have not reached calcium yet. So we would go 3p6 because we went through all 6 of those elements in that P block on the third row. So now we are at the fourth row. And if you look at your periodic table, you'll see that calcium is within the first 2 elements there. So we are going to stop in the S block on the fourth row, and we would assign the number here for the orbital or the particular element is going to be 2 because it's the second element on that row in that block. So this is what you would write for the base configuration for calcium. But there are times in which we are working with certain elements and we know that we see charges. Or, as we have heard of ions, where they have lost or gained some type of electron. So in this case, a lot of times you see the cation Ca2 plus. Well, if we reference our previous statement that things are normally at a neutral state on the periodic table, meaning there are the same number of protons and electrons, if we're seeing an element with a positive charge, that is going to indicate to us we have more positive particles than negative particles, which means we have lost some electrons along the way, whether it be by decay, whether it be by some type of bonding with that element between something else. But whatever the case may be, you may be asked to write a configuration for an element that has a charge. So here you'll see how this particular element's electron configuration changes when there's a charge involved. So here we know with calcium in its normal state, it has a atomic number of 20. So that means it has 20 protons and 20 electrons. So let's go ahead and take a look and make sure that that's what we have in our first electron configuration. So we would just add up our exponents in this case. So 2 and 2 is 4, 4 and 6 is 10, and 2 is 12, and 6 is 18, 19, 20 for that last 2. So here we have 20 protons and 20 electrons. So let's see what happens with this particular element. It has lost 2 electrons. So in this case, it means it's only going to have 18 electrons in its outer electron shells. So we would still be utilizing 1s2, 2s2, 2p6, and here is where we need to slow down And one of the things I did forget to reference, if you check your periodic table and you start with the element that you need and you count back, which means you lose those 2 electrons. So 2 from 20 would take you back to 18. So you're going to notice that your particular element is going to have the same electron configuration as a previous element if it has lost electrons. And then if it has gained electrons, it will be further on your periodic table. Okay, so let's go ahead and finish getting that completed. So with us knowing that it's going to go from 18 to 20, our electron configuration would be as if we were writing it for argon. And we know argon is in the third row. So we know with it being a noble gas, it's going to be at the far end of that third row. So we're going to go through the S block. Then we also have 3p, which is the next block. And argon rests in that sixth spot. So here is the electron configuration for calcium with a +2 charge. And let's check this. We know that it did not lose any protons, so it's still going to have 20 protons. But because it lost 2 electrons, the way in which we can double check our work is how many electrons are notated in my configuration. So here again, we have 2 and 2 is 4, 4 and 6 is 10, 10 and 2 is 12, and 12 and 6 is 18. So here we see that we have a more positively charged particle than we originally did because we have 18 electrons which are negatively charged, and then we have 20 protons, pushing that electron configuration into having just those 18 but a positive charge there on your elements. Now you may ask, well, what happens? I've seen them with negative before. So let's take a look at what happens to our um, elements when they have a normal neutral charge, and then they have then moved into being, for instance, an anion. So let's do, I say we do fluorine, okay? So let's take a look at fluorine. I'll use another color. So fluorine, if we were to go ahead, grab your periodic table, pause the video, and attempt to go ahead and try your normal electron configuration for fluorine. All right. All right, so we know that fluorine resides in this row, which is our second row, right between oxygen and neon. Okay, so we know he goes through the first row and both elements in that S block. Okay, and with him being so far down on that second row, we know he goes all the way through the second row, S block, and both of those elements. So now we have reached 2p, and we need to determine where he resides in that p block. So if we take a look, we see we've got 1, 2, 3, 4, 5. He is at number 9. So here we have 5. And we know this because it has an atomic number of 9, so means we should have 9 electrons and 9 protons. So 2 and 2 is 4, 4 and 5 make 9. So here is a representation of 9 protons and 9 electrons. And much like I promised you, let's go ahead and take a look at an anion, okay? So calcium we looked at was a cation. So fluorine, we can make sure that we understand anions because there are times when you'll see fluorine with a negative charge. If there's no number there, it is indicative or understood that there is a 1, okay? So much like I stated before, if it's positive, it has lost electrons. So we have more protons, or in this case, 2 more protons than we have electrons. So let's look at the opposite now. We have fluorine with a negative 1 charge. With that being the case, we know that that means it has 1 more electron than it has protons. So that means we're here at fluorine, and if it has 1 more electron, it's going to have the same electron configuration as neon. So here we would have 1s2, 2s2, and 2p6. And if we were to double check that, we know there were no changes in our protons. So we have 9 protons. But how many electrons? We have 2 and 2 is 4. 4 and 6 makes 10 electrons. The term in which you are actually learning at this particular moment is the fact that different elements can become what are called isometric or isoelectronic, meaning they have the same configuration as another element. So in this case, when we were dealing with calcium with a 2 plus charge, so we went from calcium's normal configuration, which gives us all the way up to 20. Calcium with a 2 plus charge has the same configuration. So Ca 2 plus has the same electron configuration as argon in its natural state. Okay? I'll go ahead and write that again in a darker color so that everyone can see. So calcium, okay? So the cation, calcium 2 plus, has the same electron configuration as argon. Much like our fluorine anion has the same electron configuration as neon. Okay? So remember when you're looking at these different things, pay close attention. Is it an element in its base or natural state, or is it a cation or an anion? Okay? Because when they are cations and anions, they are isoelectric. Okay? Meaning they have the same number or same electron configuration as a different element. So once again, as usual, I hope this was helpful. Please make note of those light bulb moments. And just like any other time, happy study.